Please welcome Mark Shuttleworth, founder of Ubuntu and Canonical.
Right, hello everybody. It's a great pleasure to be here. I'm not sure what time zones you're all in, but I assume it's good morning, good afternoon, and good evening. You'll be all over the world. Today I want to dig in a little bit to the experience of DevOps with containers on Azure, on Ubuntu. And so that's a fairly broad topic. I'll start out with a sort of high-level overview and then zoom into some demos. Everything that I'll do here is stuff that you can repeat trivially yourself. And I'll give you a bunch of URLs and pointers as to where you can find more information. So I'm the founder of Ubuntu and Canonical, and really our job here is to make sure that as a guest, Ubuntu gives you access to everything that Azure delivers with the best possible performance. And I'm delighted to say over the last 18 months or so, we've seen just tremendous collaboration between the Ubuntu team and the Azure team in the infrastructure, in the hypervisor, in the kernel. And you see the benefit of that in much better networking and storage performance, much better throughput, and access to all of the latest bits on Azure. So that's what we're building on. That's the sort of substrate that we're building on. But the piece that you'll be interested in is your applications. And so today I want to focus in on a slightly different picture than this, which is the idea that you might put a container system across a bunch of VMs and then deploy your applications on top of that container system. The apps that I'll be showing you are example workflows around TensorFlow, which is an AI, a machine learning construct. And for people on the cryptocurrency side, Ethereum, which is a kind of blockchain. I'll be doing some Ethereum mining. All on top of Azure and all stuff that you can easily reproduce at home. So container systems, there are, of course, a bunch of them. They're all good. Docker is here on the show. And Docker, of course, runs really well on top of Ubuntu, on top of Azure. Mesos, which I think comes from Twitter, and now Apache Mesos, is also a great container system. But the one I'm going to be demoing today is Kubernetes. And so digging into that, what is Kubernetes? Well, it's a collection of services that we weave together and then scale out effectively on VMs on Azure. So that's what we're going to be building. That is the sort of base construct of Kubernetes. And I want to start out by this, with the simplest possible Kubernetes and the simplest possible deployment capability or deployment approach to Kubernetes, which is something called ConjureUp. So ConjureUp really speaks to the new class of software where we have lots of different components that have to come together, and those are often spread across many different VMs, right? So if you think of what Azure means to you, Azure is this tremendous repository of capacity, right? You can tap just an enormous amount of capacity on demand, and the real bottleneck on you is how fast you can integrate all the pieces that you need into something that is coherent, right? There's not much point in getting large numbers of VMs that are sitting idle while you figure out what to do with them, right? What you really want is the ability to harness that compute or that storage or that network and do something useful with it as quickly as possible. So that's really what ConjureUp speaks to. Super easy to install on Linux. Just snap install it. There's a brew install option if you're on Mac OS as well. And when you run ConjureUp, you're going to type just this one command, ConjureUp Kubernetes, which gives you essentially just a wizard that will walk through a couple of different Kubernetes configuration options. So there are two high-level topologies. One is the sort of Kubernetes core. That is aimed at developers. So it's really as small as possible. You can run it on your laptop if you want. That exact same thing runs on Azure. And it really gives you an efficient target for dev and test. So you're using the minimal number of resources just to essentially bootstrap and test things out, figure out what you want to do. The canonical distribution takes that same topology and scales it out for resilience, for higher availability, making it really easy, effectively, to build an HA cluster and then scale that out for larger production deployments. So that tool actually looks like, I'm going to switch to that here. It walks you through a set of choices. It asks you essentially where you want to control that from. I set up a controller previously, and then you'll get to a screen like this, which essentially allows you to architect that deployment. So here I can go through the different components and I can configure them, or I might change the way I want to spread them across a set of machines. So you can see here a screen that allows me to place different components of that topology on different VMs. So this gives me a lot of flexibility with whether I want to, with how distributed essentially I want the pieces of this deployment of Kubernetes to be. It allows me to scale out individual components or shrink them back. I can put them on larger or smaller VMs. But simplistically, I can also go and change the configuration of elements. But simplistically, you just want to essentially run through all of that and then deploy them. And so this is then going to go off to Azure and request all of the resources that are needed to build that Kubernetes, the number of VMs. Then it's going to deploy all of the applications in those VMs and connect and configure them all so that they're aware of each other in a dynamic way. In the fine tradition of cooking demonstrations, here's one I prepared earlier. So I have a set of controllers, and in this controller over here, this is a scaled out Kubernetes, which I hope you can read. So that's the sort of underlying view of the Kubernetes controller once it's all sort of built out. That one's a slightly special one. I'll come back to it in a sec. Okay, so ConjureUp will give you a sort of vanilla Kubernetes. All of the compute there will be standard compute. The container processes that you run will have access to standard x86 VM capabilities. But it would be more interesting if we could do something using some of the newer capabilities of Azure. So for the next step in the demo, I'm going to dig a little bit under the hood and show you how to spin up that same kind of topology, but using GPGPUs. And so GPGPUs give you access to much faster parallel compute for number crunching type workloads. And that's where things like blockchain or TensorFlow machine learning would be super interesting. So let's do that again, essentially. Let's deploy Kubernetes again. But this time I'm going to go under the hood a little bit and show you the underlying steps in order to do it with GPGPUs. Now, to do this, you have to do a couple of things in preparation. First, you need to go to your quotas, and you'll need to specifically use the South Central US and the US East regions on Azure, because those, I think, are the two that have GPGPUs. And you'll need to look specifically for a quota element for NC type machines. And in terms of the number of cores that you have access to there, divide by 6. Each machine that you ask for is going to take 6 cores. I think the default quota is 12. You will probably want at least 18 cores if you want to follow along this demo, and that'll give you 3 VMs with GPGPUs that you could run TensorFlow or blockchain type workloads on very, very efficiently. So just go through the usual process to request additional quota on those NC type machines, and make sure that you do this on South Central US or US East. Let me dig in. So here's what you're going to do. I'm using a controller that I've already established, and it's a special controller, so it lets me build models. Oh, hold on a second, let me just switch. Just going to switch to a controller which will let me create a new model. This is pretty simple. Right, so I'm just getting a catalog of the models that I have, and we should see a new model, GPGPU demo, that's on South Central US. And so now I'm going to deploy the Kubernetes worker charm. So we're using the model-driven operation system Juju, which is what's under the hood of ConjureUp. And I'm going to deploy the Kubernetes worker charm, but I'm going to add a specific constraint to use these standard N6 instance types. Those are the instance types that have the GPGPUs. And if I fire that off, that is going to essentially just create the first part of the whole topology, and it will make sure that those ones have the GPU machines. So as soon as that's up, I can go and show the model. And here you can see there'll be 3 of those workers, and they've been mapped to 3 independent VMs, and those will be on the N6 machine types. I'm now going to deploy the rest of the canonical Kubernetes model. And what this does is it pulls in all of those other applications and allocates VMs to them, but it will see that I already have Kubernetes workers. It won't overwrite those. Effectively, it'll use the ones that I've got, which are the ones with GPUs. And the way Juju works, the charms, which encode the operations for each of these applications, will detect that there is a GPGPU there and will configure Kubernetes worker, will tag that node effectively appropriately so that later I can deploy workloads onto those nodes that depend on having the GPGPUs. So if I come back to this picture here, and apologies for the eye chart, but it becomes quite a big model. We're starting to use quite a lot of GPGPUs or VMs. You can see what's going on here. I've got a Kubernetes master, which is not HA. I've just got a single one of those. And then I've got 2 clusters of Kubernetes workers, one which I deployed to standard compute-centric machines, and one which I deployed to machines with the GPGPUs. So all of that's woven together in this model. And if I'm going to zoom out a bit so you can see this. If I show the cluster info on that, you can see, maybe zoom that back a little bit, then it's easy to read. You can see that cluster is up and running. If I wanted to check the dashboard for that, that's what's running over here. So this is the Kubernetes with both GPU and compute-centric nodes running. And here's an overview. So here are the different machines effectively in that cluster. Let me just check that I'm in the right place. I can show you. Here are the machines effectively in the model. Here is the Kubernetes view of those same machines. And you can see that they've been tagged, some with CUDA, some without CUDA, some with GPU true, some without GPU true. All of that underlying work has been handled for you by the model-driven operation system. So you don't have to worry about all of that, right? What you can focus on is your deployments. And here you can see the things that have been deployed on top of that. We have the TensorFlow. We use Helm to deploy these applications on top of Kubernetes. We have the TensorBoard, and we have a Bitcoin mining, Ethereum mining application as well. So this is TensorBoard, which is kind of a dashboard for the underlying Kubernetes workloads, for the AI machine learning construct. And there are 2 cool things to show you here. One is a picture of the this is a self-iterating kind of evolutionary model, right? It's getting smarter and smarter and smarter off the same data set. And here you can see the curve of that introspection, effectively, of the model. And then there's an even cooler visualization of the various kind of connectivity points or weightings in the graph that are being established, but that'll take a minute or two to render. Let me come over to the Ethereum Bitcoin mining. This is a real-time view of the pace of the Ethereum Bitcoin mining. I'm not exactly sure what last seen good never means, but I like the idea of a low hash rate, although maybe I shouldn't. So that's Kubernetes, standing up Kubernetes in a nutshell. 2 ways to do it: the easy way, which will just give you a vanilla one, and then the deeper way, effectively, which will give you more control over what you want to deploy. There are a couple of things that I did to that model post-deployment that you should know about. First, there's a way to connect Kubernetes up to Azure file storage so that you're using the native Azure file system for your storage in the model. I told you about using Helm charts for the TensorFlow deployment and for the Bitcoin deployment. And again, you can attach deployments that you do to particular nodes using the node information. So if I just show you that briefly, here you can see, again, an underlying Kubernetes view of the different pods that have been deployed. And there's a similar command which will give me a view of all the different nodes and the tags associated with them. So I use those tags effectively to make sure that the workloads ended up with or without a GPU, depending on the nature of the workload, effectively. So just one last thing. Once you've got that Kubernetes up, you'll probably want to wrap a bunch of other things around it for better monitoring or log analysis or handling. And that's very easy to do. So I can deploy over an existing model. I can deploy essentially another template. And what it'll do is enhance the existing model. So here is one which adds the elk stack effectively to the existing model. So if you deploy canonical Kubernetes Elastic on top of the canonical Kubernetes model, you'll go and get some additional applications, which are in the picture over here, the pieces at the bottom. So that's file beats, top beats, and other aspects of the elk stack, essentially. So that gives you deeper analytics on exactly what's going on inside those VMs and can be quite useful. So one last pointer, tutorials.ubuntu.com. If you go to tutorials.ubuntu.com and search for Kubernetes, you'll find tutorials that will walk you step by step through everything that I've done here today. That's a super useful resource. Looks like this. And here's the getting started guide, effectively, that will walk you through this process step by step if you want to reproduce everything that I've done at home. There are also a bunch of good blogs online. It's not hard to find. And all of this is documented upstream at kubernetes.io too. When you do it this way, you're taking advantage of everything that we do to make sure that the underlying components are super fast and that they can exploit everything in Azure. There is a bunch of work happening right now to integrate capabilities of Kubernetes, such as load balancing and so on, with the Azure native services. So that's all happening upstream, and then we reflect it into the charms so that you can take advantage of it very, very easily through this simple standard interface. Right, so that's everything I had for you today. I would encourage you to do that from the privacy of your own Azure credentials, and look forward to seeing you in the online community around DevOps, Kubernetes, and Azure. Thank you very much.